asked the question, what are some of the easiest ways that you can prove that the Earth is round? Because apparently this is something that we're debating. I have no idea why. That's a hard thing for me to even start talking about because there are so many proofs that the Earth is round, it's difficult to know where to start. And it's not okay to think that the Earth is flat. This is not a viable argument. I have friends who have been on the International Space Station. They have orbited the Earth once every 90 minutes. You know, I have had personal experience with people that have been up in space and can see with their own eyes that the Earth is round. And of course, we've taken all these amazing pictures from space. They're so beautiful, all those pictures of the Earth. So I don't really know what's going on right now with this Earth is flat thing, but I will tell you that this is one of the things I really enjoyed teaching my own astronomy class about, because there are proofs all around you. It is not difficult to know that the Earth is round. In fact, people have known this for way more than 2,000 years. The ancient Greeks actually had a number of really elegant, wonderful proofs that the Earth was a sphere. So let's start from the simple to the slightly more complicated. One of the things you can see yourself with a pair of binoculars is if you actually go out to a lake and there are boats on that lake, the farther away a boat is, the more the bottom of the boat will disappear, and you'll basically just see the mast of the boat. And as a boat goes farther and farther away, the last thing you will see is the very top of the mast of that boat. And that's because the boat is actually going over the horizon that's curved. And that means that as it goes farther and farther away, you see less and less of the bottom of it and more of the top of that. You can see that with binoculars, by an ocean, by a lake. It's really easy. That wouldn't happen if the Earth were flat. You would simply see the boat getting smaller and smaller and smaller as it went farther away, but you'd be able to see the whole thing with the same proportions. Now, another way that you can tell that we're on a sphere is to think about how there's something called the tropics on the Earth. And the tropics are places near the equator of the Earth where sometimes the sun is overhead in the sky. And this was actually something that the Greeks used not only to prove that the Earth was round about 2,000 years ago, but they actually measured the circumference of the Earth accurate within just a couple percent. 2,000 years ago, we've known that the Earth was round. There was a really brilliant Greek scientist called Eratosthenes. And Eratosthenes noticed that there was a town called Syene. And on a certain date, the sun would actually shine straight down to the bottom of a well. That meant the sun was directly overhead. You could look down a well and see the sun shining back at you. And on the very same date, farther away in the city of Alexandria, that didn't happen. The sun was not directly overhead. It was a slight angle. And all that Eratosthenes did was he measured the difference in the angle of the sun. It was straight overhead in Syene. In Alexandria, it was a little bit less than overhead. And he rationed that that change in angle from one city to another was probably indicative of us being on a curved surface. And you could make all kinds of measurements even between those two cities and see that the angles were different. The sun was at a different place in the sky. Using this, he actually measured the circumference of the Earth, and he got it right 2,000 years ago. So another really simple proof is that on any given date, at different cities and different places around the world, the sun is at different angles in the sky. That wouldn't happen if the Earth wasn't round. Then there are some other proofs that are a little more obscure, but they're actually really lovely. And one is to observe what happens during a lunar eclipse. Now, a lunar eclipse happens when the Earth casts a shadow on the moon. The moon actually goes dark. In fact, if you've seen one, you can actually see the Earth's shadow go across the moon. And when the moon is entirely in the Earth's shadow, the moon looks kind of dark and even kind of red colored. It's really, really beautiful. What's happening in that case is that the sun is on one side of the Earth. The Earth is in the middle, and it's casting a shadow. The Earth is casting a shadow on the moon. And as the shadow moves across the moon, you'll notice that the shadow is curved, it's round. So something like the sun that's bigger than the Earth and is able to cast a shadow of the Earth on the moon can actually show you the shape of the Earth. Aha, you might say, but could the Earth be a disk? Could it be flat, but it's actually still shaped like a disk, not like a sphere? There was a Greek scientist called Aristarchus, and what he noticed was that you can get a lunar eclipse at many different angles where the sun is. Sometimes the shadow goes straight across the moon. Sometimes it just kind of glances the moon. Just a little bit is in shadow, just on the top or on the bottom. From every different vantage point, every different angle that the sun is casting a shadow, you always get a perfectly curved shadow. The only shape that can cast a shadow that's curved from any direction you put the light is a sphere. So people have known that the Earth is spherical for thousands of years. It's not okay to say that the Earth is flat. This is some sort of strange denial. I don't know where it comes from. And it's something where I keep getting this question. We really need to put this question to bed because we've known the Earth is a sphere for a long time. There's some even well-meaning people that have kind of, they say, well, I don't really believe the Earth is flat, but I'm not really sure what to think about it. And they've asked me some interesting questions like, they've heard that that space is very hot, that when you go up above the atmosphere, the temperature of space is millions of degrees, which is true. The problem is there's basically no air at all. So I mean, the gas right around the Earth is actually millions of degrees hot. That's actually true. But there's almost none of it. There's almost nothing. Like one single proton whizzes by you at a temperature of 1,000,000 degrees. It's not the same as temperature like in the air. It's not the same thing at all. So that one was one that I get sometimes. And the other one is, I actually said this to somebody. I couldn't believe they'd never thought of it. That, with binoculars, you can see planets. You can see Saturn and Jupiter. You can see Mars with a telescope, the sun, the moon, everything else you see in the solar system is a sphere. So we're the one thing that is different. And that actually made somebody who was more interested in actually hearing information. That actually got them to think. They were like, you're right. Everything else we take a picture of is a sphere.